Hello and welcome everyone to our final presentation of our CC 341 course. This is the presentation which will show you the project that we worked on. This is our project, which is Android controlled Arduino based robotic vehicle. The name explains a lot, but the main idea behind our project was to show that we can control our equipment with the help of our Android device. This is a small prototype which has a larger vision behind it. The main idea of our project is to show everyone or bring everyone's attention to the fact that if we can make a miniature model like this, many bigger versions of this vehicle or other equipment can also be operated by a Arduino microchip and Android phone. It basically doesn't require that you have to have Arduino in the model, but the main idea is that you can operate something with your Android control device. Okay, without further ado, let's go get into our project. First of all, we will cover what kind of equipment we used in our project. First of all, we needed a microcontroller. In this case, the choice was obvious because we went for the very popular Arduino Uno. As you can see right here, we opted for Arduino Uno instead of other microcontrollers because that it is widely available in our country and can easily be obtained. Also, it costs less than other microcontrollers. At the heart of Arduino Uno board, there is the microcontroller which does all the operation and the coding and decoding tasks. Here we can see we have 13 input and output pins. Each of these pins can be configured as input or output individually. Among them, 5 of the pins are PWM control. That means you can generate PWM pulse from those 5 pins and control your device accordingly. Here we have 5 analog input and output pins. These 5 pins can take in analog input and output pins. Here are the power connectors. It has 2 ground pins, one VCC 5 volt and a VCC of 3.3 volt. After that, we have our HC06 Bluetooth module. This module connects our car and Arduino with our Android controlled phone via Bluetooth. When we choose Bluetooth, many people have asked me the same questions. Why go for Bluetooth instead we can go for Wi-Fi? Yes, going for Wi-Fi was a good idea in terms of connectivity and all that stuff, but we opted for Bluetooth as it is widely available and cheap. Another reason for going with Bluetooth is that if you are using Wi-Fi in your model and connecting your model with your device with Wi-Fi, you have to go through some extra steps that are not required in Bluetooth, such as if you're using a Wi-Fi and want to connect your device with your phone, you have to have IP address assigned in both the devices, which is a hassle for this kind of low-end stuff. So Bluetooth was used as it has a very simple socket connection product. Next, we have our L298N motor driver. This device is used to drive the DC motors that are connected with our car. This device has the capability of driving 2 DC motors or 2 stepper motors, but in our case we use 2 12 volt DC motors. These DC motors are attached at the back of our car with these wheels which throw many gears. Also, we can see there is an empty battery case with us. We have 2 ultrafire batteries that are used for this country. Here are the batteries. These batteries power the entire device. Now we'll talk a little bit about the connections. This Bluetooth device has basically 4 pins. One of them is ground, one of them is the VCC 3.3 volt, and the rest 2 are transmit and receive. The ground is common in all the equipment, so the ground of this Bluetooth device is connected to a common ground that I have taken in this breadboard from Arduino. The VCC 3.3 volt is connected to the 3.3 volt pin in this Arduino Uno. This 3.3 volt pin is capable of supplying 3.3 volts to the Bluetooth module, and thus it gets its power from the Arduino. The transmit and receive pin of the Bluetooth device is connected to the transmit and receive pin of the Arduino Uno, but they are connected in a crossover way. What I mean is the transmit pin of Arduino Uno is connected to the receive pin of our Bluetooth device, and the send pin of the Arduino Uno is send pin of the Bluetooth device is connected to the receive pin of the Arduino Uno. This is because the data that is received by the Bluetooth device is sent through the send pin, and the Arduino Uno needs to receive it through the receive pin. And if the Arduino Uno sends any data to the Bluetooth device, the Bluetooth device needs to be able to read it. Our Bluetooth device receives some specific commands from our Android control cell phone. In our code, we have write the language in such a way, pressing individual commands in our application sends out some certain characters. For example, if we press the forward button, our app sends the character F. The character F is then received by the Bluetooth device and sent to the Arduino Uno. The Arduino Uno decodes the character, and then the Arduino Uno decodes receives the character F and decodes what the corresponding operation should be. Then Arduino Uno tracks that the F means the vehicle should move forward. Then Arduino Uno tells the motor driver to rotate both the DC motors forward. Thus, forward. And if the Arduino Uno receives B from the Bluetooth module, that means the robot should move backward. Then the Arduino Uno tells the motor driver to rotate both the motors in reverse direction. The motor driver is connected to input and output pins of the Arduino Uno. As the motor driver can drive up to 2 motors, it has 4 headers. The 4 headers tells the motor driver whether the motor should move forward or backward. In our next part, we will be talking about the software that has been used in our Arduino. We will talk about the code later in details.